Welcome to Springfield AWS User Group. Tonight we're going to be talking about my experience developing on the new Apple M1. Here's a little bit of information about Springfield AWS. If you'd like to attend our meetings, look us up on a Meetup. There's the URL. If you would like to watch different past videos, look us up on YouTube. And if you'd like to chat with our community, look us up on Discord. The Discord link can be found on the Springfield developers website. A little bit about me. My name is Jason Klein. I've got about 20 years of experience in IT, primarily networking and Linux, as well as software development, primarily PHP MySQL. And I've been using macOS for about 15 years. And I switched to using the macOS as my primary development environment about 5 years ago. Currently using the JetBrains IDE PHP Storm, but prior to that, we were developing in terminal windows, which was a disaster, and I'll never go back. So when I develop projects, I deploy them primarily to Intel Linux and have been doing so for about 20 years. When we first started hosting projects like this, we would push them out to Red Hat servers as early as 2001. And thanks to a close friend who was pretty heavily involved in Debian, I made the switch to Debian Linux around 2012. And so all of our systems gradually moved over to Debian. And a lot of the things that we're using nowadays are running on Amazon Linux. We started hosting a lot of our projects in Amazon or Docker containers on Amazon around 2018. And if you join us next month, we'll talk about the transition from Amazon Linux to Amazon Linux 2 on ARM, which happened late last year. The agenda for tonight, when I talk about the transition from Intel to ARM, we're going to talk a little bit about ARM terminology, the history behind ARM, why people would consider ARM over Intel, what the ecosystem looks like and where ARM processors are used. And then we're going to dive more into Apple specific information, Apple's processor history and how they ended up on ARM, and compare specifically Apple M1 to Apple Intel. And then we'll talk about my experience running Intel applications, Intel containers, and then the situation with virtual machines on them on. And if you have questions throughout just let me know. As far as terminology goes, if you're not familiar, ARM stands for Advanced Risk Machine, and RISC, which is an acronym in ARM, stands for Reduced Instruction Set Computer, which has been around since the 80s. Thank you, Kate and Dade, for your amazing RISC quotes from the Hackers movie in 1995. But when RISC came around, it was yet another option in computing. You had Intel and IBM producing what is now known as the x86 instruction set. You had companies like Motorola producing RISC processors, and there were a few other options out there, but by far those two were sort of your main forerunners in the market. And this goes way, way back. When you are talking about ARM, it's not something new. That's sort of my point here. ARM has been around since the early 90s. The company that really established the ARM architecture, Acorn Computers, released their first processor in 1981. They shortly thereafter they built the Acorn RISC machine, or the sort of initial ARM before the ARM that we're familiar with today. In mid-1980s, they completed the ARM1 design, and you fast forward to the early 90s. This is pretty interesting since we're talking about ARM on Apple. In 1990, ARM Ltd was established by this original Acorn Computer Group, Apple Computers, and VLSI. And it's interesting that Apple was interested in ARM this early on as an alternative to Intel. But a year later, ARM Ltd, the byproduct of this collaboration, created and licensed a new ARM6 microprocessor, which was really the official first processor from that group. And that was used in the Apple Newton. So if you have ever seen that terrible, at least in modern terms, PDA, that was what it ran on. And fast forward 15 years to 2005, which now is 15 years ago, nearly 98% of all mobile phones sold had at least one ARM processor. And I thought the wording on that was interesting when I looked that up. But the idea being that mobile phones sometimes have multiple processors for different purposes. And so when they say at least one ARM processor, without deep diving into that, I have a feeling that they're also counting phones that maybe had other technologies, but used ARM for some aspect of the processing on the mobile device. So how did we get to where we're at today? Why would you use ARM processors? The big difference being, if you look at someone like Intel, they design and build the chips, and you buy a physical chipset from them, whether that be the processor or the bridge or whatever it might be. Whereas with ARM, when they design the processor, they license that architecture to whoever is using it. They don't sell them a chip, they sell them the architecture. And then the vendor that's incorporating that into their technology incorporates that architecture into their product and generally designs their own system on a chip, which when you think about any of the Android or Apple devices you might have used in the last 10 years, system on the chip is what makes them super inexpensive, super efficient in terms of power consumption, and as a result of the low power consumption, super low heat generation, and as a bonus, longer battery life. I mean, if you're using less power, you're going to have a lot more battery life. But the idea being, if you've ever built an Intel computer, you're installing the processor, you're installing the RAM, you're adding a video card, any of the other functions that you want on that computer. Whereas with an ARM chipset, a lot of those things are built into a single chip. Now, in terms of the ARM ecosystem, where is ARM used? Honestly, just about everywhere. This graphic from Cryptomathic shows a lot of the different vendors that are implementing ARM, but basically clients are using ARM in phones and tablets and VR and a lot of other technologies. I mean, you have names like Android and Unity for VR and Samsung for mobile, Oculus for VR, Microsoft for tablets. At one point, they did use an ARM chipset in a Microsoft Surface. And we'll talk a little bit more about that later. In terms of infrastructure, think mostly hosting services. I mean, that industry has been dominated by Intel, but there are certainly benefits to hosting on ARM. I mean, one of their biggest expenses is power and cooling. And if they're able to save on power and heat, why not? And so you've seen companies like AWS and Oracle adopt ARM just for the cost savings. I mean, AWS has been pushing ARM for several years, and they offer their Graviton processor, which, I mean, going back to our previous slide, they licensed the architecture from the ARM group, and they developed their own system on a chip, and they basically built their own hardware. And we'll talk a lot more about that next month when we talk about my experience moving our Intel containers and instances over to ARM. But when you look at AI and ML, the same type of thing. I mean, there are supercomputers and heavy duty processing computers that are running some of the advanced ARM chipsets nowadays. Especially when you look at IoT and embedded systems, think smart speakers like your Amazon Alexa. Those are running ARM. If you, I'm trying to look at the list here to see if anybody else stands out. I mean, some of these others like Dolby make me think if you were to buy a stereo receiver these days, it would not surprise me if there was some sort of ARM technology in there. And that goes back to the fact that a lot of these companies that were building these devices would have to design all of their processing from scratch or purchase chips and incorporate chips products from other companies like the Intel into their products. And then they would be restricted to whatever offerings are available. And finally, automotive. When you think about infotainment and navigation systems, it's the same situation. That people were building their own hardware, and now that there's an open architecture available, they can license that and incorporate that. And so you end up with companies that are essentially building what would likely end up being your common automotive infotainment or navigation system. So now let's dive into Apple specific history. I mean, we're going to talk about my transition from Intel to ARM, but this isn't the first time that Apple's made this kind of pivot. If we look way back into their history, the Apple Macintosh, which really had its run from about 84 to 1995, ran on a Motorola 68K RISC processor. And then most of the computers that a lot of us are familiar with nowadays, at least the predecessors to their Intel lineup, were their PowerPC computers that made their last run in about 2005. And those were 32-bit PowerPCs, G2s, G3s, G4s. I mean, they had iMacs in the little like raspberry and teal and whatever color all-in-one iMacs before they were flat panel computers. And when they were basically running Mac OS 9 on those, Mac OS 9 was designed for PowerPC. And when they released Mac OS 10 around 2005, 2006, it was designed to run on PowerPC and Intel. So you could run Mac OS 10 on either platform, but around 2006, they started to release their first Apple computers. And I want to say that those first computers technically had 64-bit Intel chips in them, but the OS was a 32-bit OS. You fast forward one more year and they were already running Mac OS 10 as 64-bit. But when they started to make that transition, right in the Mac OS 10 era, they launched Rosetta 1 to assist with the transition from PowerPC to Intel. A lot like we're seeing now, and I'll talk a little bit more about that in a second, but the idea being, if you went to run an app from, say, Adobe, Photoshop, or anything else that had been designed for your PowerPC, they would convert it on the fly and run it on your Intel CPU. So this is not new territory for them. I mean, I remember them doing that. It was not the smoothest process, but it worked. So fast forward another 15 years, 2020, 2021, and now Mac OS 11 is released, and they release Rosetta 2 to assist with the transition from Intel to ARM. It's the same idea that they followed before, where they had Rosetta 1 running PowerPC apps on Intel. Now Rosetta 2 runs Intel apps on ARM. We'll talk a little bit more about that in a second, but the takeaway here is this isn't the first time they've made a major pivot in infrastructure or architecture. They've moved from RISC to PowerPC. I don't know that there was really a transition there. I'm pretty confident that things that ran on the original Apple Macintosh did not run on the Power Mac. But once they they moved from the Power Mac to the modern Apple computers on running Intel, they did make a pretty easy transition path, and they had the experience doing that, and used that experience to build an even smoother transition from Intel to ARM. So let's talk a little bit about Apple Intel versus Apple ARM. So if I mentioned if you're building an Intel computer, you're typically finding a processor, finding a motherboard, finding RAM, finding a video card or GPU, and the different components that go along with that, and you're combining that all together. Intel's always been awesome about one, backward compatibility, and two, being modular, being able to bring all of these components together and have that compatibility layer between all the components. But that comes at a cost. It's great in terms of free and open market, and I know people balk all day at walled gardens and lack of interoperability and things like that with Mac. But since that's the environment that they have, and that's the life that they're living, they were in a position to implement a system on a chip. And if you look at this graphic of the M1 off to the upper right, what they've done is they've basically incorporated the CPU, your processor, and the GPU, your video card, and this lower part, it doesn't have a graphic, but basically your memory, all into a single chip. So, I mean, if you think about an Intel, whether that be an Intel Apple or Intel anything else, generally your video card is going to have its own video memory or video RAM, and your computer is going to have its own RAM. And it's not uncommon for your computer to have 8 or 16 gig of RAM and your video card to have 4 or 8 gig of RAM. And when your video card is doing its work, it's like reading and writing from that RAM. But when the CPU is telling it what needs to be done, it's literally having to read from the system memory and send it over the PCI bus or whatever interconnect is happening to the video card, and then that's having to write it to its memory. And that's you take a big hit in performance because of the extra reads and writes. Whereas this architecture, this system on a chip concept, allows the main processor to write information to the memory, and then basically hand off those locations to the video card and say, here's the memory that you need to work with. I'm not transferring it to you. I'm just telling you where to find it. And so rather than the delay of sending that information, it happens instantly. That's one example of a benefit of the system on a chip. But if you go out and read a little bit more on the differences, you'll find a few other examples that just add up to making a big difference in performance. Another thing that is different between the Intel Apple computers and the ARM Apple computers is that these new M1 chips have 4 CPU cores that are considered high performance and 4 CPU cores that are considered high efficiency. So think very expensive in terms of power usage and very efficient in terms of power usage. And so if you're transcoding a video, you're going to be using those 4 high performance CPU cores. But if you are checking your email, you're going to be using those high efficiency CPU cores. And the interesting thing about the system on a chip is that it can run specific cores or even all 8 cores at the same time. So that's a lot different from the Intel approach, where you have 4 cores and they can go into more of a power saving mode, or they can go into a high performance mode. And then they use a concept called hyper-threading that allows you to run 2 things on a core at a time and go back and forth, but it has its own issues. It's great, but it's not perfect. And so you end up with a performance benefit from having 8 independent cores versus 4 cores that are sort of shared across 8 processes. And then another thing that we're seeing in this particular design with the M1 is that they've built in a neural engine. And you see this in other chipsets and graphic cards and things. But the idea being, don't think of this as something you're going to use to do a lot of machine learning training, I mean, it can certainly be used for that, and it can, and there are claims online that this particular setup gives you a 15x performance increase over traditional setups, whatever that might be. But think of this in terms of if you're opening Mac Photos or something else that's going to use some sort of machine learning engine. In Mac Photos case, it'll scan my 30 or 40,000 photos and detect faces. And it can do that a lot faster with this chipset because it's able to use a hardware implementation rather than purely a software implementation. And those 16 cores are separate from your CPU cores. So those are able to work while your cores are doing other things. And I mean, all said and done, when you consider the factors of just how much different this architecture is, you end up with a user experience that's similar to an iPad or an iPhone. I was shocked to be able to turn on the computer and have basically instant on. I mean, you open the lid and there's not a delay waiting for it to get your login page ready. It's just there. And I'm sure that there's a little bit of black magic happening where they're probably doing something to force it to load or be ready. But I wouldn't be surprised if a lot of that can be attributed to the different architecture. Also with loading Mac applications and scrolling through large data sets and things like that, I've just been very surprised by how much more fluid the experience is. The applications load much faster. There isn't a delay in scrolling in places where I've had issues in the past. Just overall, very impressive that they've been able to rethink how or incorporate the system on a chip approach that's common in mobile and implement that on your desktop or laptop. I'm not giving them the credit of engineering this from scratch. I mean, it's been around. It's just that they're probably the first ones to really pull it off in terms of a desktop environment. So let's dive into what it looks like when you run applications on this thing. I mean, moving from Intel to ARM, to give you an idea, I mentioned that I've been on Mac for almost 15 years. My first Mac was the end of the PowerPC era, and then I've seen the whole Intel lineup, and now I'm moving over to ARM. So when I first fired up the new M1, my hope was that I would be able to find the M1 version of most of my applications and not have to run Intel applications. I just made the assumption that by being an early adopter for something like this, I would be in for some heartache if I had high expectations. And so my hope was to find the M1 or ARM version of any applications that I could. But right away, I mean, within the first 2 or 3 applications I installed, I saw a pop-up like this that said, to open this application, you need to install Rosetta. Do you want to install it now? And I thought, okay, well, let's go for it. It's inevitable. I clicked install. A few seconds later, maybe up to 30 seconds later, it was done. It had already basically pre-downloaded or they had installed the binaries with the OS. So I wasn't waiting for a hefty download, which was nice. And as soon as that was installed, the Intel-based installer popped up and my application installed just like it would have on an Intel Mac. No problems there. And then I ran the application. There was a little bit of delay the first time I ran it because what's happening is they're using a concept called AOT, or ahead of time translation, where when you are running an Intel application or an Intel binary on an ARM computer the first time, it's going to convert that code to ARM code, and it will sign and store that on your computer in such a way that the next time you go to run that application, it won't run the Intel code at all. It will just launch the ARM code. And so you do feel a little bit of delay the first time you install or run an app, especially if it's a larger application, because it just takes a little bit longer to convert the code, but we're talking seconds. I mean, I've never waited minutes for it to start. You were talking somewhere between 5 and 30 seconds, depending on the size of the app. And then after that, you never feel that. And then they also have a concept called JIT, or just-in-time translation, where, I mean, you think about some of the Intel code that might have to run that can't really be downloaded once and then run many times. Early on, when I first switched over to the M1, some of the browsers didn't have native support for ARM yet. So I was technically running an Intel browser on an ARM platform, and they were able to use ahead of time translation for that. But if I were to visit a website that was sending some sort of Intel-based, I don't know, WebAssembly or something like that, the Mac has the ability to run just-in-time translation and basically convert that Intel code to ARM on the fly. And I don't know if I've used that. I mean, the whole point is Rosetta 2 worked so well this whole time that I don't know when I'm using it unless I get that pop-up that says you need to install Rosetta 2. After that first time I install an Intel app, it's pretty transparent to you. I mean, you might feel a little bit of delay the first time you install an app and wonder, okay, is this an Intel app? Is that why it's taking a few seconds? But otherwise, my experience has been surprisingly amazing. I really expected to have trouble either with my IDE or with my build tools, whether that be Webpack or any of my homebrew lineup. And I was just surprised that everything worked so well. And we'll dig into homebrew and some of those other specifics in a second. But as far as applications go, zero problems on my end. I'll mention a few hiccups in a final slide, but they weren't anything that affected the runtime of the applications. Now, for my development environment, I think I mentioned it in the meetup intro, but we primarily develop on PHP and MySQL. Specifically, we use the Laravel framework, and we deploy our projects to containers hosted by Amazon ECS. They're Docker containers, and we use Amazon's code pipeline to detect when source changes happen and to trigger a build and trigger deploy. And we'll talk more about that next month. But the gist of it is, when I first made the switch, all of our containers were still Intel. And I really like to be able to build and test containers locally if I'm making container specific changes. Like, let's say we're fine tuning something with, I don't know, the Nginx settings or PHP FPM or something like that, where I want to be sure that the settings are working as expected before I wait for a build to happen out in the cloud. It's just faster. You have a much shorter feedback loop if there's some sort of issue. So I definitely wanted to be able to build our Intel containers locally and make sure that things were working before I would deploy something or commit something that would be deployed. And so let's talk a little bit about that. First off, if you're going to build containers on your Mac, you're going to use Docker. I'd assume that that's the go-to. That's what I've been doing. If you're using Docker on an M1, you're going to use the preview edition. And I included a screenshot showing what that installer looks like. I mean, even when I go to run Docker now, it has the icon looks just like we see in the screenshot with the big red bar. So I'm reminded constantly that I'm using a preview version. But other than that visual reminder, I honestly have been pretty impressed with the preview. The Docker is going to tell you that ARM containers are faster and use less memory than Intel containers. They'll also be very upfront and tell you that not all images are available for ARM64. I think this might be resolved within the last few weeks, but one of the more common containers that was slow to adopt was MySQL. And they would specifically tell you, when you go to boot up the container, use the flag platform or parameter platform Linux AMD64, and they'll just download and run an Intel image under emulation. And the neat thing about Docker is they've had cross-platform builds and emulation for a little while now. It might be considered experimental, but it's not something they released specifically for the Apple M1 environment. It's something that they've had in their offering for a little while. And the idea being that if you're on Intel, you can build an ARM image and run it and test it. If you're on ARM, you can build an Intel image and run it and test it. And I experienced no problems with that. I was very impressed. If my third bullet here talks about if you need to build or test or deploy images to Intel and ARM, you can use the Docker Build X tool, which is their cross CPU architecture build tool, to build Intel and ARM at the same time. So in this particular example, I'm using a buildx build command, and I'm specifying the platform Linux AMD 64, which is Intel, and Linux ARM 64, which is ARM. You can specify one or the other or both, and it'll build both images and let you test them both, which is amazing. I was shocked that that worked out of the box. Really, when I announced this meetup topic, I thought it was going to be a lot more doom and gloom, like here are all the things that I ran into, but I've been shocked that everything's been such a smooth transition, and huge kudos to the Docker team. I mean, when the M1 arrived, they had an early preview 7 or something of Docker, and it had a minor issue that was related to some of the other software I had installed, and that cleared up in the latest preview. I mean, there was a workaround available for it, but that was the only time that I felt like I was having to go out of my way to make it work. But I was shocked that I didn't have to download extra binaries or follow ridiculous instructions or anything like that to build Intel images on an ARM computer. It was pretty amazing. So now we'll get into the doom and gloom. This is about my only doom and gloom slide that I've got. Intel virtual machines. I mean, I've had great luck with Intel applications. I've had great luck with Intel containers, but I'll be honest, Intel virtual machines are a no-go, just a big no. There are ways, but it's, as far as I can tell, and from what I've seen, we're not there yet. You've got companies like Parallels and VMware and VirtualBox that have provided virtual machines on Intel Mac for who knows how long. And Parallels and VMware have already announced virtualization products for M1, but VirtualBox has specifically said they will not be supporting M1 because their mission is to provide virtualization for x86 platforms on x86 hardware, which is fair. I mean, they're focused and they know what they're going to do, and this doesn't fit in that wheelhouse. But, and the big but with that is, if you're looking at the offerings from Parallel and VMware, they are not offering virtualization for Intel. They're offering virtualization for ARM. So don't expect virtualization products to equal Intel emulation. I mean, if you want to run Windows, Intel Windows on your ARM, you're probably going to be waiting a little while, if that's ever offered. Where we stand right now, I mean, companies like Parallels and heck, even the built-in virtualization in the Mac can run Linux ARM. We can run Windows ARM. And there have been reports of people running macOS, basically macOS 11 ARM in a virtual machine. And a side note with this is I believe starting with Big Sur or macOS 11, they've moved away from a lot of the kernel extensions that you would normally expect people to use for host-based firewalls and virtualization and things like that. And they've provided native implementations of a lot of the things that people were having to implement through third-party extensions. And as a byproduct of that, they now have, from what I can tell, pretty awesome support for virtualization. Think HyperX, but for Mac. So, or I mean, Hyper-V, but for Mac. So the Windows virtualization that's built in on Windows OS, either Pro or Server, Mac is doing the same type of thing. And so you don't have to run some extra layer to virtualize. You can use their built-in framework. And when companies like Parallels are tapping into that, all they're really doing is making it possible for you to run some ARM OS on your Mac ARM OS. And so with that being said, let's look at Windows in particular. Windows ARM can run ARM apps. So if you're going to install Windows ARM, you need to download and install a Windows ARM application. So you would need to find Windows Photoshop for ARM. Microsoft is working on an emulator that will allow you to run 64-bit Intel apps on Windows ARM. I mentioned that Microsoft Surface has had an ARM version, and that included an emulator that was supposed to allow you to run 32-bit Intel apps on that Microsoft Surface. But I've heard that it had mixed results, and I'm frankly surprised that they didn't offer a 64-bit emulator early on if they were going to dive into the ARM environment, but that's not what they have. So if you were to run, in the perfect world, if you were to run Windows ARM on your Mac ARM as a virtual machine, and Microsoft had that emulator, you could run 64-bit Intel apps in Windows ARM and you'd be fine. I mean, when this emulator would be essentially Microsoft's version of Rosetta 2 that would allow them to transition from Windows Intel apps to Windows ARM apps. And there's no reason that can't run in a VM. It's just not ready. So that's something to look forward to. Windows ARM isn't really an official product. Windows ARM, it does exist. It, I believe, is really, from Microsoft's standpoint, something that they look at as an embedded architecture. So I don't know that there's a retail SKU for that. If you download it, you're basically downloading some sort of beta or preview or trial version, something that's short-lived. It's not something that you're buying. And so given everything that I've read up on and everything I've seen through this experience, I would not be shocked if within the next 12 months, there's a Windows ARM SKU and you can buy Windows ARM, or you buy Windows and you can run it on Intel or ARM. Maybe it doesn't even have to be a separate SKU. But as it stands right now, if you buy Windows, my impression is you're buying Windows Intel and your license is not transferable to Windows ARM. So you end up in this funky Windows test environment. But hopefully between that and them releasing an emulator that can run 64-bit apps, you'll be able to run Windows whatever in your on your Mac ARM in a VM. In the meantime, until that Windows or Microsoft releases an emulator, your next best option would be for the Apple M1, the ARM processor, to have an emulator of some sort that could run Linux Intel or Windows Intel, QEMU being an example. And I only bring that up because QEMU is the emulator that Docker is using to run like Debian Intel in Docker or whatever other Intel images. That's the magic that's allowing Docker to run Intel images on ARM. But running a CLI on ARM is a lot different than having to run a full-blown graphical operating system on ARM, because you have a lot of other drivers involved, especially the video drivers. And I'm guessing that's where the hangup is in being able to run Windows through an emulator on ARM at this point, is having support for whatever video drivers Windows would need to use to interact with video on the Mac. And then finally, just a last mention for people that aren't familiar with the environment of moving from Windows to Mac. There's an app called Crossover. I had not heard of it until I started digging into this during my transition, but apparently it has a great following, and it's built on the Wine project, which for folks that aren't familiar, would allow you to run a lot of different Windows applications on Linux. But they've used that same concept or that same technology to allow you to run Windows applications on Mac natively. They don't run in a VM. They run through this compatibility layer, some sort of proprietary crossover software that allow you to run, basically double click on an icon and start a Windows application on your Mac. And even though crossover is designed for Intel, the reports that I'm seeing basically say that if the app is supported in crossover for Intel, Rosetta can handle the rest or fill in the gap and basically run that Intel Windows app through crossover on an ARM Mac. So that's something else to look at if you're on the fence about making a transition. You could potentially look to crossover for a solution. Finally, I didn't mention this in the agenda, but I'm as a developer, I rely heavily on the command line. I rely heavily on installing open source tools on my Mac, and all of that happens through Homebrew. I've been using Homebrew for a long time. It's part of my standard build. I'd assume that you're in the same boat if you're developing on Mac. And when I first received the M1 and installed Homebrew, I had to run it through the Rosetta compatibility layer, and it installed Homebrew for Intel on my Mac. But since then, last month, they released Homebrew 3, and that included native support for ARM or for Apple M1. So as of right now, I've done a clean install of Homebrew, and it's all ARM. There's no Intel code running behind the scenes. So think with Homebrew, Mac ships with PHP and Python and things like that. Oh, Nginx, maybe Apache. I don't know what other open source projects they ship. Maybe an older version of MySQL, but the key is older version. I mean, all of those things that they ship, by the time they ship them, are outdated. And if you install them through Homebrew, you generally get the latest version or something reasonably recent. So when we're developing with PHP, I mean, we develop and test in containers, but from a performance point of view, I'll make sure that I have the same version of PHP installed on my Mac, and I'll do some of my development directly on the Mac hardware, not in a container, and then I'll run it through its tests in the container before I deploy, and that way I can find out immediately if there's an issue without waiting on our pipeline to tell me that there's a problem. But Homebrew allows me to do that. It allows me to install PHP 8.0, 2 or 3 or 4 or whatever we're on, and the latest version of Python and all of that stuff. And by installing the ARM version, it's just that much faster, because if you install things that are built and compiled for ARM or specifically for the Apple M1, I've noticed night and day difference. And I'll show an example here in a little bit of a performance difference just between something I'm running that was built for Intel and running on my Mac versus something that was built for ARM and is running on my Mac. But be aware that not all Homebrew packages are available for ARM. Just like we talked about with Docker, not having ARM images for MySQL quite yet. We run into that same boat where some of the vendors just haven't caught up and built ARM packages for Homebrew. So if you were to install a package, it might fail, but you can install Homebrew for ARM and Homebrew for Intel side by side, since they live in separate directories. And I listed those there. I mean, traditionally, Homebrew's lived in user local bin, but now the new Homebrew 3 for ARM lives in opt Homebrew. So here's some WTF moments. I make it sound pretty rosy, and honestly, I'm pretty impressed. It is, but I've had some times that I was less than happy. The first bullet, not one of them. First bullet's minor. I've installed some applications. At the very end of the install, it would say that the install failed. Application started fine. I don't know what that was all about, but definitely an artifact of the transition. Number two, and I included a link to the story if you want to dig in and hear about the disaster. But basically, when I upgraded from Big Sur 11.1 to 11.2, it was a utter failure. It was stuck in this boot sequence where it would just like flash a pink or purple screen and reboot, and I'd type in my password and it would try to boot again, and it would just keep rebooting, and I couldn't repair or recover. I couldn't boot to safe mode. I eventually, after spending almost a day trying to come up with a solution, I wiped and reinstalled. I mean, I have decent backup, so it wasn't a big deal. I was more frustrated by the fact that it even happened, because over the last 15 years, I've not run into an upgrade that failed like this. So I thought I was doing something wrong. Honestly, don't know if it was M1 specific, but you can read all about it on Reddit. I have a feeling, I mean, my gut tells me it was probably something related to that early version of Docker, but I don't have anything to back that up, and it very well could be something completely unrelated. Because I mean, when I was first installing crap on this thing, we were talking early previews and betas of all kinds of stuff. But the benefit of that is, by doing a clean install, almost everything that I installed the second time around had native versions. And really, Docker, I think, is the only thing that I'm still running that's considered a preview. And it has been rock solid ever since. So take that for whatever it might be worth. So as far as Docker Desktop Preview, the early version, Laravel Valet, which allows me to super easily run Laravel apps on the Mac and not necessarily in a container. They had a known compatibility issue. I linked to that here. That was resolved in this latest Docker preview. And like I said, I haven't had any issues since then. But basically, Docker was making some assumptions with how they were going to allocate IP addresses for their containers, and that conflicted with what Mac was doing with their framework. And they changed how they're handling that, and that seemed to clear up the issue, because the conflict I was having was basically Docker containers couldn't do DNS lookups because of Laravel Valet was installing DNS Mask, which is a DNS server on my local computer, and that allowed me to type in project.test, whatever the project name was, project.test, and in my browser, it would go to that local DNS server, and if it found it was a .test domain, it would try to resolve it to a project, and if it wasn't, it would just forward it on to whatever the OS was using for DNS. But Docker did not like that at all. So that got worked out. And I had to do some dancing anytime I wanted to work around the issue and stop Laravel Valet or stop Docker. I don't remember the exact sequence, but I was able to work around it when I'd run into that. Definitely felt like cutting edge stuff, though. I was feeling the bleed for sure. As far as other Apple M1 things, this is more of a hardware issue, but seriously, 2 USB-C ports, not enough. Not gonna lie. Like, I don't know what they were thinking. It's most likely a limitation of the system on a chip. I mean, it has its benefits, but I could see where it might come with some sort of limitation in terms of connectivity. But between that and this was my transition to USB-C, so it was my welcome to dongle hell, and so that gave me a little bit of frustration, but I've managed through it. And right now, as I'm recording on my M1, I am running off of I've got basically power and video cable right now, and I had to unplug something else to connect video. So sort of annoying, but for the little bit that I'm connecting things to the ports, I haven't invested in a hub. So I just switch things out. But I definitely, something that could be overcome. If I had 4 ports, I'd be just fine. And as far as other WTF moments, I mean, I'm months into this and Apple still has not released native Acrobat or Photoshop or Illustrator. I mean, as a developer, those aren't things I use day to day, but there are still things that I like to use on the side. And I'm just surprised that if I look at my list of all of my applications installed. If I were to go to the system report and look at all of the Mac specs, there's a menu item that says applications that lists all of the applications that are installed. It shows multiple entries for some applications, especially when you look at Adobe, because when you install Adobe, it installs a bunch of crap that you probably didn't want or need or know about. But long story short, they added a new column to that list. It lets me look at the architecture and I can see if the application is made for Intel or Apple Silicon or if it's universal. And almost everything that I have is either universal or made for Apple Silicon. There are probably 30 things that are still Intel. And I want to say about 23 of those things are Adobe related for those 3 apps, which is ridiculous, but it is what it is. And then finally, I understand that Intel Windows isn't going to run on ARM natively, meaning there isn't going to be a way to virtualize an Intel operating system on an ARM processor, but I'm pretty shocked that Microsoft hasn't nailed their Intel emulation for Windows ARM, considering they've offered a Surface product with ARM for years, I think. So if that were complete, I don't think we'd have any issues. You'd see people firing up Windows ARM, using their emulator to run Windows Intel apps, just like Mac is allowing you to run Mac Intel apps on Mac ARM. So I feel bad for any of the Microsoft Surface people that are running that ARM service that can't run hardly any apps, but hopefully they'll overcome that soon. Now, on the flip side, things that I have been super excited about. So Apple M1 for the win. I was prepared to not have an escape key, and I was pleasantly surprised that this touch bar computer has a physical escape key. Most people that see the computer, that's one of the first things they notice. They're shocked that it has an escape key, because for a while, touch bar computers didn't have a physical escape key. So I like to mash on that thing when I'm escaping out of things, and so it's nice to have. The other thing that I liked, I wasn't really sure what would happen about how they'd handle a power button, but on the opposite end of the touch bar, there was a combo power button and unlock key, which I didn't think I would use all of that much, but I sure do like not typing my password. So using that thing, it's been awesome. And that's probably not an M1 thing. That's probably been around, but you've got to keep in mind I upgraded from a 2015 to a 2020 model. So I skipped about 3 generations there. And then I already mentioned this, but the user interface response time, amazing. Instant on, instant load of apps, just super fluid scrolling, things that the same apps on my Intel Mac couldn't do. Now, to be fair, even though it was a 2015, it was the highest option. I mean, it was completely decked out. And so when you look at the benchmarks, that particular computer wasn't too far behind some of the 2019 Intel. So it wasn't like I was comparing Slouch to the brand new thing. I mean, it was decent, but still very noticeable in terms of applications running on there. I included a link to a specific set of screenshots for, I'm drawing a blank, Handbrake. I converted some video from one of the past meetups in Handbrake for some reason, and thought, I wonder if Handbrake's running native, and realized it was running as Intel. And I went and found out that there was a M1 native version. So I ran the exact same conversion again and included screenshots in that Twitter feed that basically say, holy heck, this was 47 or 53% faster just by using Handbrake for M1 instead of Handbrake for Intel. And I mean, all you can really attribute that to is being able to take advantage of some of these features in the system on a chip that we talked about, like shared memory and some of the other built-in hardware calculations that that an Intel app might not be aware of. Another one, I a lot of people like their laptops because their laptops warm their laps, but this one is an exception. Always cold, amazing. I mean, my laptop was never that hot, but it was never cold like this. I mean, I'm feeling the bottom of it right now, and it's not warm. And there was one time where it got hot and it made a weird sound, and I realized that it does have a fan, and basically was going back to Adobe, not dev related, but um, Adobe was misbehaving and had some core sync threads that were running and basically pegged out the 4 performance CPUs at 100%, and it was getting warm. But as soon as I killed that off and made it behave, it was fine. It never did it again, and I'm seriously surprised or shocked that I haven't run into more issues running Intel things on ARM. I really thought that that would be an issue. I've also been super impressed that a lot of the tools that I use day to day for development, whether that be tools that ship through Homebrew or my IDE, or when I say tools that ship in Homebrew, even Node and things like that for compiling some of our front end stuff. None of that's given me any issues, either early on when I was having to run the Intel versions, or now running the ARM versions. Like I haven't run into anything since last month when I switched to Homebrew 3 that I use on a daily basis that wasn't available as Homebrew ARM. So I haven't, since the big crash and burn of Big Sur 11.2, I haven't had to install Homebrew Intel at all, which is just shocking. I figured that I would still be running into things that would need Homebrew Intel, but I have not. So kudos to everybody involved in Rosetta 2 and Homebrew and Docker. I mean, was shocked I was able to build Docker images, honestly. A lot of the tests that I run, you can run on Docker or ARM images. So I was also, before we transitioned all of our infrastructure over to ARM, I was doing local testing with the ARM images, and then I would test in Intel just to be safe if it was something extremely, I don't know, if it was just a really significant change to the container image. But for the most part, I mean, the way I looked at it, the whole point behind Docker images is that you should have a lot of consistency from image to image and from platform to platform. So I was able to run tests in the ARM versions, but I was very happy I was able to run the Intel versions as well. And we'll talk more about that next month. This is really just a precursor to that, to hopefully answer questions about the M1, so that we didn't get bogged down about that as an aside in talking about moving our AWS resources over from ARM to Intel. And with that, here are some different resources that I found along the way that people might find handy if you're in the transition or if you're considering the transition. There's a fantastic website, isAppleSiliconReady.com, that allows you to look for your favorite apps and sort of see what the status is, whether yes, they'll run, or yes, they're native, or no, they won't run, or there are known issues. And so you can visit that site and type in VS Code or PHP Storm or Photoshop or whatever it is, Transmit or CyberDuck or whatever it is you use day to day, and get a feel for where they stand. And that site has been very well maintained throughout. There was a link to the latest Docker M1 preview, a link to the Parallels M1 preview if you're needing to run Windows or Linux on your Mac. That will definitely let you run those, but it's going to run the ARM version. There's also a link to, hold on, too many clicks. A link to more instructions for people who might want to run Linux ARM on their Mac without using virtualization software like Parallels or VMware, because the framework for virtualization is built into the OS now. If you can figure out the commands, you can technically boot whatever image. And someone has put together a set of scripts that'll make that pretty easy and straightforward. So this GitHub website has a set of scripts you can use to basically run the latest Ubuntu image on your Mac without installing virtualization software. Literally, your Mac OS is running Ubuntu as a VM. And finally, speaking of Linux, if you're a diehard, or Linus Torvalds, who said, man, I'd like one of those Apple M1s if I could run Linux on it. Currently, somebody's made that happen. You can boot an Apple M1 directly to Linux. The Corellium project, I believe, has worked through how to make that happen. I mean, I guess they've followed the iOS devices over the years and have, the only reason they were able to pull this off is they'd already basically, my impression is they'd already been able to run Linux on some of the iOS devices. So think a replacement for an Android tablet, Linux on an iPad. I haven't seen that. I don't know if that's exactly right, but that's my impression. And so they've basically taken that knowledge and applied it to the M1, and they've been able to boot an M1 directly off of Linux. So not something that I've tried, but when I ran across it, I thought that'd be a nice thing to share. It seemed obscure enough, it might be hard to find. And with that, I know I said questions throughout, but since you've been pretty quiet, any questions? And Justin, I know you don't have AV, so if you've got any questions, just throw them in the chat.
Yeah, so you've been working with development and stuff like that. What's your experience been with PHP Storm and the JetBrains products?
No problems at all.
And
I've
like
been surprised.
Debugging and stuff.
Yeah, I mean, I'm using the debugging tools, building, using the integrated like linting and testing. I just honestly, I haven't run into anything that has been an issue above and beyond what would have been an issue on an Intel Mac. I mean, obviously you get into some of the Xdebug stuff and it can get hairy, but that's, I feel like that has been polished just sort of right around the time this has happened, to where even that was a little easier. But I haven't had any situations where there was something that I would normally do that I couldn't not do on the M1, which shocked me. Honestly, I thought tonight when I first suggested and scheduled this topic, and I know it got pushed back a month, but I thought it would, by the time we had the meetup, I would be listing, here are the things to watch out for, and here are the things I ran into. And other than that WTF slide, it's been pretty smooth sailing. And the JetBrains stuff has worked out great. And I've seen reports that the VS Code stuff works out fine too.
Okay.
Yeah.
And what about like meeting software and some of that kind of stuff that has the hardware and things?
Yeah. So meeting software, I've used Zoom extensively. I've used WebEx a handful of times. No problems with either of those. Trying to think of what some of the other third-party meeting software is.
Bluetooth devices can be kind of finicky with meeting software sometimes.
I'm using a Bluetooth device right now, man.
Yeah.
That's been zero problems. Yeah, that's my audio for tonight. And honestly, I live off of that. We've got some software that we use for our phone system. And so between hopping into video conferencing meetings or just hopping on the office phone, I rely on this. And I'm sad to say that my poor little Bluetooth headset is probably about due for an upgrade. I mean, it's an oldie but a goodie, and just an old Plantronics device. And so I'll move to something else, but it hasn't had any trouble like syncing up to my M1 and my phone and my tablet. And that's, until you brought it up, it's not something I would have even thought to mention, because it's just worked.
Oh, that's cool.
But no, I'm glad to stick around and answer questions. I'm going to wrap up the recording, and I appreciate you guys coming out. And if you have more questions, or if anybody watching this online has questions, feel free to hop into our Discord and answer any or ask any questions later on, because I'm not planning on switching away from my new Mac anytime soon. I've had this thing since early December, and just been real happy with it. So I don't see anything changing. I'm looking at the chat list now, and I see Justin said he used crossover on Intel Linux and it worked well. So that's good to know. I didn't realize crossover was available for Linux too. So that's great. And,
I'd
and
heard
he
of it
said he's
previously, but I hadn't used it.
okay. Well, yeah, I'd never heard of it before. So I was pretty surprised to hear that. I'm going to stop the share and stop the recording, but you have other questions or want to chat, we can definitely do that.